Welcome to our first lesson on the mathematics of chemistry. We begin the mathematics of chemistry with a topic known as conversion factors. In some references, textbooks, and online resources, you'll find it listed as dimensional analysis, also as factor label method. Each of those will become apparent as we go through the process. Really what chemistry is a method of looking at ratios, and it's really just algebra applied. You find that as we weigh things and we count with weighing, we count with measuring, that this method of conversion factor analysis really helps us and simplifies the math behind the chemistry. What you're going to want to do with this PowerPoint presentation, you want to go through this conversion factor PowerPoint. Go through it a couple times if you need to. You can go back and forth. You can pause it. You can slow it down. I'm going to be writing over the top of the slides. So just like you would if we were sitting in class and you were taking notes. You will want to take some notes in a notebook on this to have to refer back to. If you haven't got a calculator yet, you're going to want to press the pause button on this and get a calculator, get some scratch paper ready. There are going to be 3 problem sets throughout the course of this PowerPoint presentation, and so you're going to want to try each one of those on a nice sheet of paper, and I'm going to ask you that you turn those in on Wednesday so I can give you a grade on those. If you have any questions in the meantime, please email me in regard to these conversion factors, or post it in the forum up above on the Moodle, and see if other people have some answers to it. Okay, so let's begin with this idea of conversion factors. This is really the definition and the overall idea behind what a conversion factor is. What we're looking at here is a way of changing from one unit to another. If I took a meter stick that had inches on one side and centimeters on the other, and I held it up to a table, I could read that result in inches. Maybe it's about 34, 35 inches. When I turned it over, it might read 95, 96 centimeters. Now, I didn't change the height of the table. What I changed was the measurement. What I changed was the units in which I measured in. So even though the numbers changed, those two ideas are equivalent to each other. Conversion factors can change from one unit to another. It's a ratio fraction made from 2 measured quantities. And what you're going to find is that these fractions are always equal to 1. And so what we want to do is we're canceling out units, not necessarily canceling out numbers. Okay. What's this look like when we do it? An example of a conversion factor is, let's just say, for example, I have 4 quarters. You know that 4 quarters equals $1. You say, Mr. Hines, we know this. I got it. I understand it. But to help us, we can make 2 fractions out of this. 2 things we call conversion factors. And these 2 fractions are known as 2 conversion factors. And they're equivalent to each other. If I take 4 quarters and put it over $1, that would be the same thing as putting $1 over 4 quarters. Both of these factors equal 1. They're the same thing. We know from algebra that if I put 4 over 4, that equals 1. If we were, and you know this from labeling, what you're going to find eventually is that if I put apple over apple, it's the same thing. That also equals a factor of 1. With that said, when you're making conversion factors, you have to make sure that you have the correct units with the correct number. What you see in front of you now in set number 1, which I would like you to do on a separate sheet of paper, is 4 ratios. They may be correct, they may not be correct in the way that they're written. Please determine which of these 4 are legal, and by legal we mean correctly written, and which are illegal and not a correct ratio. An example of something that would not be legal would be if I wrote the phrase, let's say there's 12 eggs in 1 dozen. But what if I wrote 12 dozen is the same thing as 1 egg? That would be an example of an illegal conversion. Now, unless you had like a hollow egg in which you had things in it, but that would have to be very specific. For our purposes in general terms, you're not going to have 12 dozen equal to 1 egg. It just doesn't make sense for the purposes. So try set number 1 and see which of those A, B, C, E. I guess I should have a D there. Sorry about that. You can make that one D. A, B, C, D are legal and which are illegal. For set number 2, we want to make 2 conversion factors, and that's the biggest thing in beginning this process is, are you able to make a conversion factor out of equivalencies? We already did this first one, and so you know that we put 4 quarters is the same thing as $1, or $1 is the same thing as 4 quarters. So in set number 2, you're just going to be setting up conversion factors. So you should have a total of 8 when you are done with those.